Welcome back to another Kafka Connect exercise. In this hands-on demonstration, we'll walk through features of the Connect REST API using basic command line examples. Let's start by running the command that gets basic Connect cluster information, including the worker version, the commit that it's on, and its Kafka cluster ID. Note that the cluster ID sets this cluster apart from other Connect clusters that may be running a separate set of connectors. Next, let's run the command that lists the plugins that are installed on the worker. Note that plugins need to be installed first in order to be called at runtime later. Kafka does ship with a few plugins, but generally you'll need to install plugins yourself. The best place to get them is Confluent Hub, where you'll find a large number of plugins and a command line tool to install them. Recall that the Docker containers for our 2 Connect workers included commands to download and install 4 connector plugins from Confluent Hub. It's a bit difficult to spot the different plugins on the command line output. We can run the command again, though, and pipe the output to the JQ command to get it in a more easily readable form. Now it's much easier to see the details for each of the available plugins. These plugins need to be installed on all workers in the Connect cluster so that if a connector instance or task is moved to a worker due to a rebalance, the plugin is available to run it. Next, let's create a connector instance. To do so, we put or post a JSON file with the connector's configuration to a REST endpoint on our Connect worker. Put is somewhat easier because it will create the connector if it doesn't already exist, or update it if it does. If it already exists and there's no update to make, it won't error out. So put is the idempotent way of updating a connector. Let's now run the command that returns a list of all existing connectors. We also have a command that will allow us to inspect the config for a given connector as follows. And we can also look at a connector status. While the config command shows the connector's static configuration, the status shows us the connector as a runtime entity. If something is wrong in your setup and you don't think a config change would help, or if you simply don't need a connector to run anymore, you can delete it by name. Let's verify the delete request succeeded. While we're on the subject of deleting connectors, you can make a nifty interactive delete list with the tool Pico by piping the connector list standard out through it, finally xarging to a curl call to the delete API. Remember, though, that if your connector fails, the details of the failure belong to the task. So to inspect the problem, we'll need to find the stack trace for the task. The task is the entity that is actually running the connector and converter code, so the state for the stack trace lives within it. Here we just see the task status of running, but if the task had failed, we would see the stack trace details. We'll go through these steps in the troubleshooting module for a failed connector, and when we do so, the stack trace details will be included. For now, let's talk about restarting connectors and tasks. If after inspecting a task, you have determined that it has failed, and you've fixed the reason for the failure, perhaps restarted a database, you could restart the connector with this command. Keep in mind, though, that restarting the connector doesn't restart all of its tasks. You will also need to restart the failed task using this command. Unlike restarting, pausing a connector does pause its tasks. This happens asynchronously, though, so when you pause a connector, you can't rely on it pausing all of its tasks at exactly the same time. The tasks are running in a thread pool, so there's no fancy mechanism to make this happen simultaneously. Let's pause one of our connectors now. And let's verify that both the connector and task are paused using the status command. And that's confirmed. Let's now resume the connector and its tasks. And again, let's verify both are once again running. Moving on, we also have a command to display all of the connector's tasks. This information is similar to what you can get from other APIs, but it's broken down by task, and configs for each are shown. The last command we'll look at is one that returns a list of topics used by a connector. This became available as of Apache Kafka 2.5. This shows the topics that a connector is consuming from and producing to. This may not be particularly useful for connectors that are consuming from or producing to a single topic. However, some developers, for example, use regular expressions for topic names in Connect. So this is a major benefit in situations where topic names are derived computationally. And that's it. We've completed our tour of the Kafka Connect REST API.